Sorting and grouping materials. Introduction. Other than our food and clothes, about which you have learned in the previous chapters, our world is full of a huge variety of objects. If you look around yourself in the class or at home, you will find many objects in your surrounding having different shapes, sizes, colors and uses. It may be chairs, tables, desks, sofa, books, newspapers, toys, cycles, plates, bowls, buckets, mugs, and so on. In order to group the objects, we have to take some common quality so that we can sort them out. If you look for objects that are round in shape, your list can include a thali or plate, a ball, a round watch or clock, a bottle lid, round fruits, a chapati, a paperweight, and so on. Similarly, if you sort out objects on their quality of being edible, you can include all the food items or dishes that you listed in Chapter 1. A more reasonable method of sorting objects would be to list them on the basis of the materials they are made of. For example, if you sort the objects made of wood around you, your list may include chairs, desks, tables, sofa, walking sticks, and so on. In the same way, you can sort out objects made from steel like plates, spoons, kitchen utensils, gate, window frames, and so on. You can also sort out objects made of glass, paper, plastic, cement, and so on. Thus, we see that we can sort out the objects present in our surroundings by selecting any one quality, such as shape, size, color, and so on. However, the best way to sort out objects is to separate them on the basis of the material they are made of. Thus, we can say that grouping together of similar objects is called sorting. Materials in our surrounding. There are many materials with which you may be familiar, while there may be some objects made from materials that you do not recognize or know. In some cases, one material may be used to make different kinds of objects. At the same time, two or more kinds of materials may be used in making an object. Think about it. Why is a football made of leather from outside and not cloth? Or why is your pencil made of wood from outside and not iron? What will happen if your cooking utensils like your frying pan is made of plastic? It would melt and catch fire when you put it on a gas stove. What would happen if your tumbler was made of paper? The tumbler would become soft and open up the moment you fill it with water. Materials and their properties. If you think about the materials that are used to make some useful objects, you will find that in making an object, the choice of material depends on the use of the object and the suitable quality or property of the material. The sorting of materials depend on the properties of materials. We shall learn now what these properties are and how they are useful. Appearance. The way something looks is called appearance. The look or appearance of materials are different from each other. A piece of brick looks different from a piece of glass or a piece of wood. However, a group of materials may have the same appearance, such as a piece of glass and a piece of plastic that you use to cover your notebooks. Similarly, most of the metals have a similar kind of appearance. Texture. There are some materials that feel hard, while others feel soft when touched by hand. A piece of metal feels hard, while cotton, wool, or sponge feels soft. But between a piece of wood and metal, it is difficult to make out which is harder, because on touching, both feel equally hard. Activity. Take a piece of chalk, a piece of wood, a piece of metal, a candle, and a brick. All these materials are solid and also appear hard. Now, scratch a candle and a chalk one by one. These can be scratched with your fingernails. Take a metal key and a piece of wood. When you scratch the wood with the metal key, the wood gets scratched. In the same way, the metal can scratch a brick. This shows that a metal has more hardness than a brick. Thus, solid materials have two main properties: texture, appearance. Metals are mostly harder than other solid materials. They also have shine, called luster. Solubility. Solubility is another criteria to sort materials. Water is considered as universal solvent, so the material which easily dissolves in water is called soluble. For example, salt, sugar, alum, and so on. And the material which does not dissolve easily in water is called insoluble. For example, sand, chalk, iron, and so on. Materials like mud are called partially soluble. The property of a material to dissolve in water is called solubility. A liquid that dissolves other substances is called a solvent, and the substance that gets dissolved is called a solute. Activity. Take some samples of common solid materials such as powdered chalk, sawdust, common salt, sugar, and some soil from the garden. With the help of your teacher, take 5 test tubes and put them in a test tube stand. Fill the test tubes with water up to half their length. Add a pinch of different materials in each of the test tubes. For example, in the first test tube, you can add salt, then sugar in the second test tube, garden soil in the third test tube, chalk powder in the fourth test tube, and sawdust in the fifth test tube. Take a stirrer to stir the water for 5 minutes. After stirring, what do you observe? Write your observations in the table. Miscibility of liquids. Liquids like lime juice, vinegar, spirit, and so on, which mix well with water, are called miscible liquids. And the property of the liquid to mix with water is called miscibility. Liquids that form a separate layer and do not mix with water are called immiscible liquids. Some gases also dissolve partially in water and have a useful role to play. Oxygen gas dissolved in water provides oxygen to the plants and animals that live underwater. Similarly, dissolved carbon dioxide gas provides raw material to water plants to prepare their food in the presence of sunlight by the process of photosynthesis. Take some common household liquids in small quantities. For example, hair oil, cooking or refined oil, kerosene oil, spirit, vinegar, lime juice. Set up your test tube stand and fill the test tubes with clean water up to half their length. Add about 10 drops of each liquid in a separate test tube, half filled with water. Use a glass stirrer to stir the liquids one by one. We observe that hair oil, it is immiscible and therefore floats on. Refined oil, it is immiscible and therefore floats on. Spirit, it is miscible and mixes with water. Vinegar, it is miscible and mixes with water. Kerosene, it is immiscible and therefore floats on. Lime juice, it is miscible and mixes with water. Some liquids mix well with water, others do not mix and form a separate layer either above the water or below the water. Density. Liquids like some hair oils or cooking oils sink in the water, while some immiscible liquids like kerosene float on the water. If you put insoluble solids and immiscible liquids in water, some will float while some will sink down. From the observations of the given table, we see that some objects float on water while some objects sink down, because some objects are lighter than water while others are heavier. 1 ml of water weighs 1 gram, or 1 liter of water is 1 kg in weight. If an object or material of 1 liter weighs more than 1 kg, it will sink in water. If 1 liter of a substance weighs less than 1 kg, it will float on water. Take a small bucket and half fill it with clean water. Take some solid materials such as coins, keys, a small piece of wood, a stone, plastic objects, paper plate. Put these solid materials one by one in the bucket containing water. We observe that coins sink in water and have more density than water. Plastic ball floats on water and has less density than water. Stone sinks in water and has more density than water. Keys sink in water and have more density than water. Wood floats on water and has less density than water. This weight-volume relation is called density. There are two boxes, one large and one small, but they weigh the same. This means the small box has more density than the large box. The density of water is 1 gram per ml. If an object has density greater than 1, it will sink in water. And if the density of the object is less than 1, it will float on water. You may have seen ice floating on water because its density is 0.9 gram per ml, which is less than 1. The density of a liquid also decides the fact whether it will float or sink in water. If you take a dense liquid like honey and put a coin on it, the coin will remain at the top and will not sink in honey because the density of honey is much more than that of the coin. Optical property. The property of any material to allow or stop light to pass through is called its optical property. You may have seen that shops and big showrooms have glass covers on the outside for the people to see clearly the items being sold. During the night, these shops are lighted up and become more attractive. Back at home, our doors are metallic or wooden, and often our glass windows are covered with curtains so that others are not able to see inside the house. The materials through which light passes easily and we can see through them are called transparent materials. On the other hand, materials through which light does not pass and we cannot see through them are called opaque materials. Other than transparent and opaque materials, there are another type of materials which allow the light to pass through them, but we cannot see through them. Such materials are called translucent materials. Translucent glass is mostly used for window panes in bathrooms or sometimes in office doors, where light from outside is required, but privacy has to be maintained. Can you list some materials that are transparent or translucent? Activity. Take a white sheet of paper and hold it against a hand torchlight. What do you observe? Light from the torch is not visible. Now, in the center of the paper, put 2 drops of hair oil. Hold it against the torchlight. What do you observe now? You can see the light coming from the torch through the oily patch. Need for classification. Classification of objects is necessary because it makes it convenient to locate objects. It makes it easier to study the properties of objects and observe any pattern in these properties. If we know the property of one member of the group, it can give an idea about the properties of other members of the same group.